Welcome back. Let's start by determining the sample size. So if we don't know the sample size and we want to know the sample size. So we are talking about a simple random sample. And here's the formula. So again, if you are asked to find the sample size around a population mean, here is the formula that you're going to want to use. And what do we recognize there? We see that we've got that critical value. If the computed sample size n is not a whole number, remember to round up to the next larger whole number. So if we are dealing with an unknown sigma, then we need to use the range rule of thumb to estimate it. So that's a good first step. So first we want to know, do we know sigma or not? If we don't know sigma, then we estimate sigma, and then we use the formula. Otherwise, we can just go right ahead. Assume that we want to estimate the mean IQ score. So we're talking about mean, always important. We're talking about mean for the population of statistics students. So we want to know the mean, population mean. And they give us sigma equals 0.15. So that's great. So we don't need to use the range rule of thumb here. They give us our sigma. So how many statistics students? So that is asking our sample size, right? So we know we're going to be looking for n. Must be randomly selected for IQ tests if we want 95% confidence that the sample mean is within 3 IQ points of the population mean. All right, so here's our formula when we are looking for the sample size. So we've got our critical value, our sigma, and our margin of error. So they give us 3 IQ points, so 0.03. That's our margin of error. They give us our sigma. And then they give us our confidence, and that's going to tell us our critical value. So if it's a 95% confidence, then the alpha is 5% or 0.05. Alpha over 2 is 0.025. So the corresponding critical value is 1.96. These come from earlier slides on your cheat sheet. So let's plug in what we know. So 1.96 times 0.15, 0.03. We're going to square that. And we type that into the calculator. So I typed that in and I got 96.04. And remember that we always round it up. So our n is going to be 97. We need 97 statistics students to be randomly selected for this. And here's a little bit more about that. All right, so we spent a lot of time estimating a population mean when sigma was not known. Now we're going to talk about when sigma is known. So let's go back to our hypothesis testing and confidence interval flow chart. This you can get on Canvas. So again, let's follow it through. Are we talking about proportion or mean? So we're talking about mean and we're talking about sigma is known. So let's see how to use this. So we're talking about mean. So we're going to ignore the proportion size. We're talking about one mean. You guys don't even know what two means is yet. And they're basically saying, is the population standard deviation known or not known? So earlier in the slides, we were doing this, but now we're in this section here. And we're talking about confidence intervals right now. So we're going to be using a Z interval. And here is the steps for that. You can also use our TI-84 spreadsheet function. So if you come down, and I like to use the table of contents, we're in confidence intervals, not one proportion, one mean. And remember, they say here population is unknown. They tell you about the T interval, but the population is known. They talk about the Z interval. So that's always good to know. All right, so it's in tests for Z interval. And here is the margin of error for when sigma is known. And let's do an example. Use the 15 birth weights of girls given below for which n equals 15. Okay, great. So they're actually giving us some stats here. And x bar equals 30.9. So we don't actually have to put all this data in. They're giving us the stats here. So construct a 95% confidence interval estimate of the mean birth weight of all girls by assuming that sigma is known. So we are looking for the mean and sigma is known, right? So that means we're going to be using our Z interval. So we're going to go to stat, tests, and we're going to go to Z interval. And they actually give us the statistics. So the sigma is 2.9, X bar is 30.9, and n is 15, and the confidence level is 0.95. So we can calculate it here. That's 29.432. Remember, we're talking about the mean. And let me grab the upper, 32.368. Here's a little more about that. Go ahead and give this a try and press play when you're ready to see the solution. And there we go. A quick reminder here that when sigma is not known, we're going to be using the t-distribution. And then when sigma is known, we're going to be using the z-distribution. Remember that you can always use your flowchart here as a reminder.